Um, okay, so let's begin with the chi-square test. Further math statistics, chapter number 3, very important chapter. So, what is a chi-square test? It is also a test of significance, or we can say a test of hypothesis. In which cases it is a test of hypothesis? It is a test of hypothesis when you are testing the dependency of two set of data. I mean, if they're dependent or not, or if they're independent or not, two set of data. Dependent or not, or sometimes, we say that it's a goodness. Goodness means, suppose you are thinking that you might use a binomial probability to evaluate a set of data, or you can use the normal probability to evaluate a set of data, or you can also use Poisson probability to evaluate a set of data. So three kinds of probability: binomial, Poisson, and normal. We have studied binomial and normal in S1, Poisson in S2, but I will still be showing some sort of Poisson here. I mean Poisson probability here. So একটুখানি দেখাবো আর কি। Okay, so when you are uh, testing the independency of two data, that means if two set of data they're independent or dependent, or if a particular selection, or if a particular probability is valid to evaluate a set of data, এই দুটো জিনিস, these two things when you are testing, তখন আমরা ইউজ করবো চাই স্কোয়ার টেস্ট। তো ফার্স্টে আমরা ডিসকাস করবো, we will be discussing about the dependency of two data. Suppose um, we have been there at the pizza bar eating pizza. Okay, so two types of pizza were there. Suppose normal pizza and naga pizza. Okay, আর আরেকটা সাইডে মনে করে আমি বললাম যে enjoyed or did not enjoy. Okay, did not enjoy. Okay, suppose এখানে we have calculated that there are 51 people who enjoyed normal pizza and 41 people who enjoyed naga pizza. So how many in total enjoyed pizza? We can say it is 92. Okay. And suppose 15 people did not enjoy the normal pizza and 43 people did not enjoy the naga pizza. Okay. So it's 58. Okay. So 58 people did not enjoy any pizza. Now, how many people has taken normal pizza? So 15 plus 51. If I say, let me add them first. Yes, 66. And how many people dealt with naga pizza? 84. Okay. So what is the total number? Whatever you say from both sides, what is the total number? Add them, or we might add them. Anyone. If we add them, we get 150. 92 plus 58 gives 150. Or again, 66 plus 84 also gives 150. So now if I say, what is the proportion or probability of the people who enjoyed Naga pizza? I mean, who enjoyed pizza? Oh, okay, okay. Uh, who enjoyed the pizza? Who enjoyed the pizza? I'm getting distracted. Who enjoyed the pizza? I'm looking writing Enzo. So 92 people enjoyed pizza out of 150. Okay, so now out and how many person did not enjoy the pizza? Did not enjoy. Enjoy. So 58 by 150, right? Okay. Now, so here you have to determine that whether the people who enjoyed people who enjoyed normal pizza or did not enjoy normal pizza or enjoyed the Naga pizza or did not enjoy the Naga pizza, are these, you know, these data, are these data really independent of each other? I mean, are they biased somehow? Like, is it like someone who enjoys the normal pizza did not enjoy the Naga pizza? I mean, is it like something like that? I mean, are the data some way they're linked or they're just random, independent of each other? সেটা আমাদেরকে বের করতে হবে. That thing we have to find out. এটা করার জন্য আমাদেরকে we have to calculate the value of chi squared. What is the value of chi squared? It is the sum of you know, the observed frequency minus the expected frequency, I mean the expected number, whole squared, divided by expect sorry, divided by the, it's not actually like that, I'm sorry, the sum of the entire thing divided by the expected. It is like this. Or, you know, we can also write this in another way. Okay, this one way is good, other way is not good. So here what you have are the observed frequencies. Now we would calculate the expected frequencies. We would calculate the expected frequencies from the probability values. Okay, so this is the proportion, wait. So this is the proportion of people who enjoyed the pizza, and this is the proportion of people who didn't enjoy the pizza. So out of this, okay, let's consider the proportion of people who enjoyed the pizza. Okay, so out of all this, wait, let me grab the calculator. So out of all this, how many people enjoyed the normal pizza? Okay, so how many people had normal pizza? 66. See, look, 66 people had the normal pizza. And out of 66, so how many people enjoyed the normal pizza? So it is like 92 over 100. Because there is a probability. I mean, out of 150, 92 people enjoyed the pizza. So out of 66, how many would enjoy the pizza? And this 66 is the normal pizza. So this value would tell you, this value would indicate that how many people would enjoy the normal pizza, right? How many people would enjoy the normal pizza? So it seems like the value would be 40.48. Okay. Similarly, How many people enjoyed the Naga pizza? So the proportion of people who enjoyed pizza is 92 over 150. So out of 84, how many people would enjoy? And this 84 is the Naga pizza. So enjoyed the Naga pizza. It's 51.52. 1.52. Similarly, this value, this is, so we would be for this, for the second column, and for the second row, we would be using did not, the proportion of did not enjoy, because that is the did not enjoy. Okay, so what is the proportion of did not enjoy? 58 by 150. So how many people had Naga pizza? 66, right? So how many people did not enjoy the Naga pizza? It's 66 in times 58 by 150. And we are getting 25.52. ঠিক আছে? We can, this is actually logical, because out of 150 people, 58 people did not enjoy the Naga pizza. So out of 150 people, 58 did not enjoy the Naga pizza. So out of 1, it will be 58 by 150. So out of 66, it would be 58 by 150 into 66. And this 66 is the Naga pizza. Number of people who had Naga pizza. I like that. Similarly, the last one would be, it would be 32.48. These are all the expected frequencies. So expected frequencies has to be calculated from the probability or the proportion. Now, if I say that you do the chi-square test, chi-square test, so it would be the sum of observed minus expected. That means, for example, in the first, for this case, it would be like 51 minus 40.48. 51 minus 40.48 whole square plus 41 minus 51.52 whole square, right? 1.52, 40 was 51. Okay, fine. Plus 15 minus 25.5 plus 43 minus 32.48 whole square divided by the expected frequencies. That means 40.48 plus 51.52 plus 25.52. No, I'm doing mistake. I'm sorry. It is like divided by 40.48. Okay. Divided by 51.52. Divided by 25.52. Divided by 32.48. এখানে the sum of that, because আমি সবগুলোকে add করে দিছি. I've already added them, so sum is not needed. And I mean the summation sign is not needed. So the value of chi square would be 12.626. 12.626. Okay. So this is how you calculate the value of chi squared in all the cases. A test of hypothesis. So when you are trying to do the test of hypothesis, তখন যেটা করতে হবে সেটা হচ্ছে you have to calculate the degree of freedom, then calculate the critical value for the for the given the level of significance of the critical value. Okay, and then you determine that which hypothesis is correct. এখন এই এখন in case of degree of hypothesis, there is something to say. A degree of hypothesis, এখানে we have to say something. I mean degree of freedom. So degree of freedom is symbolized as this one. The symbol is new. NEW. I mean its name is new. So এখানে the number of parameters that you are calculating will tell you will tell you that what is the degree of freedom. Here there were total 4 values, and what we have calculated, what we have estimated, we have estimated the chi-squared value. It was not given, so we have estimated one value, the chi-squared value. So we subtract 1. So the degree of freedom would be 3. It's like that. Suppose data were there and you have estimated the chi-square value, subtract 1, and you have also estimated the mean, for example, then again subtract 1. And for example, you have also what do you say? You have also estimated the standard deviation. So you again subtract 1. Yes. The number of parameters that you are calculating, maybe the test statistic value, the mean value, the standard deviation value, that for each parameter you have to subtract 1 from the total set of data, and that's giving us 1. Okay. So, and the level of significance would be given. So that is how you do it. Now, for example, we have calculated just a chi-squared value. Just one parameter we have subtracted. So we have subtracted just 1. Okay. So the thing is, the degree of freedom is 3. And suppose the question is telling you that we do the test of hypothesis at 10% level of significance. That means, 50%. That means the critical region would be, I mean, 90%. So degree of freedom 1, and it's 90%. That means 0.9. So if you see the chi-square table, you will see that at 90% level of significance, or 90% confidence level for the degree of freedom 3, for the degree of freedom 3, wait, for the degree of freedom 3, degree of freedom 3, the value of the test, the critical value for the chi-square, the critical value for the chi-square is, wait, the critical value for the chi-square is degree of freedom 3. Okay, so it is 6.251. 6.251. So the test statistic again is telling us that the number of boxes that we can move at most 6.251. But for this test statistic, we have moved 12.626 boxes. That is way, much away from the highest number of boxes that you can move along the graph or along the data set or on the number line. But here the test statistic says to move 12.626 boxes. So it's out of the acceptance region. So we don't accept the null hypothesis. That means we would say that, okay, null hypothesis is rejected. That means the data are not independent. The data are somehow dependent on each other. Okay. Okay, so this is how you do this case statistic. And these kind of problems you will see in the worksheet that I have given. Now, let's go to the goodness of fit. I mean, suppose it says that which kind of probability will fit, maybe binomial, maybe normal, or what. Okay, okay. So let's look at some examples. Just a moment. Oh, ও আরেকটা জিনিস যেটা বলতে গেছিলাম সেটা হচ্ছে এই চাই স্কোয়ার টেস্ট করার সময় the expected frequency, it must be greater than 5. It should not be below 5, because below 5 hole the value is so small, to create a lot of uncertainty. So it must be above 5. এখন যদি above 5 না আসে তাহলে জোর করে above 5 করে নিতে হবে। আমরা সামনে দেখছি কিভাবে আমরা জোর করে above 5 এটা করতে পারি। ঠিক আছে? So let's look at some examples. Let's look at a few examples. Okay. So goodness fitting test. এটা আমরা একটু দেখি। Okay. For example, ধরো um, কি বলবো, ধরো নাম্বার না, I'm talking about lummies. ধরো এখানে বললাম স্ক্রিন টাইম, বললাম স্ক্রিন টাইম, আর এখানে বললাম যে নাম্বার অফ, I mean frequency. I mean how many days, I mean out of, for example, 70 days, how many days does Lamis have screen time? 0 hours, then 1 hour, 2 hour, 3 hours, 4 hours, 5 hours, then 6 or more hours. So suppose the frequencies are like 6 days out of 70 days, Lamis have no screen time. 13 days, 26 days, 14 days, 7 days, 4 days, 0 days. Okay. And suppose তোমাকে বললো যে এই যে here this distribution, can we use Poisson probability for this distribution? We have to calculate this at 5% level of significance. Before going into the solution, let's get to know that what is the formula for Poisson probability? Probability of for R number of observations, I mean R number of success, is e to the power minus mu, where mu is the mean, then mu to the power R divided by R factorial. R factorial. Okay. So mu is the mean. So we have to calculate the mean. Okay. Keep in mind that we are calculating a parameter. So mean, we can easily calculate the mean. Okay. As usual, 0 into 6 plus 1 into 13, sort of like that. তো আমি যদি ওভাবে করে, if I try to find the mean, then I will get the mean value. You know the formula of mean. Just we have seen O levels and then AS level. Then you will get the mean as 2.214. 2.214. Okay, 2.214. Now let's calculate the probability for each of the values. Let me copy it. Okay. So for each value. So what is the first value? The first value is 0. So these are basically the R values. These are all the R values. Okay. The success that we are talking about. Now you have nothing to do with frequency. Just about it's all about the you know the data that you are concerned with, not the number of data. Because number of data has already been included in the mean. It has already been included in the mean. Okay, fine, very fine. So as we were saying, so what would be the probability of this? The probability of this, so R is 0. So if you put R 0 here, uh, 0 here, then you are left with just this, e to the power minus mu. That means e to the power minus 2.214. So what would be the expected frequency? I'm writing it in short, expected frequency. So expected frequency. So okay, so this is the probability. That means this is the proportion. So expected frequency will be proportion times the total number. That means this times 70. So we are getting 7.65. Okay. So what is the probability of this? The R value is 1. R value is 1. So it would be e to the power minus mu times mu to the power R divided by R factorial. This is the probability. And what would be the proportion of this specific value 1? The proportion would be probability times the total number, just like before. So, and you will get the value here as 16.9 in point. I'm writing it about below 9. Similarly, you will get the values of, I mean, the expected value or frequency of this one as this is what 2. You will get 18.74. For this one, 14, you will get 7.66. For this one, 5, you will get 3.79. And for this one, you will get 1.79. But here is the problem. You see, the problem is that these last two values, they have the expected frequency below 5. So what should we do? We should add them, right? Let's add them so that we will have a value more than 5. What do? We combine them. We, oh my God, no. What do we do? Oh my God. Read this. Hmm. Okay. So let's add these two things up. Oh my god. I just don't like this. Okay, so we are adding them up and we are writing is at 5 means more than five. And so the frequency would also be added to 5, and the expected frequencies would also get added. The expected frequencies would become 5.18. 5.18. Now you do the chi-square test. If you do if you calculate the values of chi-square, you get 4.40. The degree of freedom would be data that we are dealing here is about the number of it's now how many? 1, 2, 3, 4, 5, 6. 6. So 6. I square value. Since we calculate the mean, so we again calculate the degree of freedom is 4. And suppose that we have to test at 5% level of significance. So at 5% level of significance, at degree of freedom 4, the value of chi squared would be um, something like no, it's 4 degrees of freedom at 5% level of significance. 4 degrees of freedom. Wait, let me check the table. 4 degrees of freedom at 5% level of significance. It is 9.488. 9.488. Okay. So the critical value is 9.488, but our value is 4.4. So we can highest go up to 9.488 so that our null hypothesis might be accepted, but we have got 4.4. So it is within our acceptance rate. That means, okay, yes. So this entire thing can be good or well modeled by Poisson distribution. Okay, so this is the. Now remember this. So when you are using R, that is the success. Success is from the X values, not from the R value. Okay, let's do this again. ওকে, তো যেটা বলছিলাম, এখানে দেখো যে গুডনেস অফ ফিট টেস্ট ফর দ্য বাইনোমিয়াল ডিস্ট্রিবিউশন, এখানে দেখো সেম জিনিস কিন্তু ওই যে এখানে তোমাকে কোশ্চেনে বলেছে যে you have to do the binomial distribution test to see that whether this model can be evaluated by binomial probabilities. So first time null hypothesis set করলাম. We are setting the null hypothesis that yes, it can be modeled by binomial distribution. Then we set the alternate hypothesis that no, it cannot be modeled by binomial distribution. Okay. And then what do? We are calculating we already know the formula of binomial distribution, right? The formula of binomial distribution, it's like probability that of R number of success is NCR P to the power R, that is success to the power R, and Q to the power N minus R, where Q is the failure. So এটা তো হচ্ছে ফর্মুলা বাইনোমিয়ালের। এখানে erase this, erase it from here. Okay. So now এখানে তাহলে what is the value of R? What is the R value? I mean, what is the N value? Look, we have already told, আমি আগেই বলেছি যে এখানে frequencyর সাথে তেমন কোনো সম্পর্ক নেই. Frequency is only here to calculate the mean and the standard deviation, nothing else more. So the R and the N all are linked with the X values. So these are the X values, the number of marked as X at the X values. What is the highest X value? The highest X value is 6. So this 6 is the what do you say? The N value. N. 6 is the N. Okay. And all other values are the R. All other values here was 0, 1, 2, 3, 4 are the R values. So now let's find the probability of success. I mean, yes, let's get this. It is thought that the distribution, okay, each box, I'm reading from here. Each box holds 6x. Unfortunately, it finds that new box tend to mark the X. The data on the number of X mark of 100 boxes are collected. Okay, so we have to calculate it out of the 100 boxes. Okay. So what's the mean here? The mean here is the formula, just simple formula for calculating the mean, it is 3.45. So the mean is what? The mean is 3.45 here. The mean is 3.45. The mean is the formula. So the formula of mean that is available to us. ওটা দিয়ে আমি করে ফেললাম. ঠিক আছে? And now we have the value of n. What is the value of n? The value of n is 6, the highest value. The value of n is 6. Okay. And we know that for binomial distribution, NP gives the mean. So NP is 3.45. So from here, you can find the value of P. ওই দেখো, value of P has become 0.5. And our the expected height, same goes here. It is given, and as at the Okay.